Hi, welcome to my video on the chain rule, extra examples number 4. And I always like to do more examples to make sure you can comprehend the chain rule. Find y prime as a single fraction. If y equals 4x e to the x squared, subtract ln of x to the fourth divided by x cubed. So y prime is the derivative, that's the d dx. So we have a subtraction here, but if you notice, this is a product of two functions, 4x and e to the x squared. So let's call this one f and g, and this is a division, and let's call it j and k. So when we do a product, derivative of a product, we do f prime g plus f g prime, and when we do a quotient, we do j prime times k minus j times k prime divided by k squared. So let's do the derivative. So it's 4x, that's the derivative of the f times the g, which is e to the x squared, plus 4x times the derivative of g, which is e to the x squared. So I'm just, without doing the derivative, writing it down first. Now we have a subtraction, so this is subtraction, and because that's going to be a fraction, let's write it like this with a subtraction there. So we have, this is derivative of j, so that's the ln of x to the fourth derivative times k, which is x cubed. Subtract, remember that subtraction sign is right here, we're subtracting these two, and because we're doing the derivative of a quotient, we have a negative, so that's the ln of x to the fourth times x cubed derivative, make that derivative sign there, all over k squared, so it's x cubed being squared. So let's do the derivatives. Again, we have a product here and we have a quotient here. And notice we're subtracting. Very important. I just put the subtraction in there, cause a little bit more confusion. So the derivative of 4x is just 4. So that's e to the x squared plus 4x. Now, this is the derivative of a composite function, so let's use the chain rule. So the derivative is e to the x squared, and the derivative of the inside, which is x squared, so the derivative of x squared is 2x. Subtract, and let's do this. Okay, so the derivative of ln x to the fourth is, this is a composite. It's made of ln of x and x to the fourth. So it's the derivative of the ln of x to the fourth. So that's 1 over x to the fourth. And the inside is x to the fourth. So the derivative of x to the fourth is 4x cubed times x cubed. Subtract ln x to the fourth, and we got the derivative of x cubed. The derivative of x cubed is 3x squared, all over x cubed squared. 3 times 2 is 6, or x cubed times x cubed is x to the 6th. Now let's simplify, so let's go, that's 4ex squared. 2 times 4 is 8. X times x is x squared. E to the x squared. Subtract, again, make it, simplify this inside now. So this is x to the 1 over x to the fourth divided into, here I have, this is x to the 6th. So that becomes 4x squared. Subtract 3x squared ln x to the fourth. I put the 3x squared in front of the ln because with this I have a multiplication here. So is this the ln of x to the fourth included in this? Or so notice that I have a multiplication. So I'd rather put the monomial in front of the ln over x to the sixth. And let's continue. So we have y prime 4ex squared plus 8x squared e to the x squared. And we have this as a single fraction. So notice now that we have we can factor out the x squared on the top here. So we can take an x squared out because it's a common factor in these two expressions. And so x squared divided in 4x squared gives me a 4. And x squared into 3x squared ln x to the fourth is 3 ln x to the fourth all over x to the sixth. Notice I could do faster, but I'm just taking my time to make sure it's explained. So 4ex plus 8x squared e to the x squared. And we cancel here, so we get a subtraction. So x to the fourth, x squared divided into x to the sixth becomes x to the fourth on the bottom. And we're left with 3 ln x to the fourth. Now we want it as a single fraction. So we have a fraction here. So there's a couple of ways I can do it, but one way I'm going to do it is I'm going to express this as two fractions. So we have x to the fourth. So now make it over that's a fraction. So I can go negative. So that's 4 over x to the fourth minus 3 ln x to the fourth over x to the fourth. And you can't cancel this because this is the ln of x to the fourth divided by x to the fourth. And now we notice we have two fractions here. So we want to make it one fraction. So I want this is understood to be over 1, and this is over 1. So the common denominator is x to the fourth. So we're going to multiply the first fraction, x to the fourth over x to the fourth, 4ex squared. And this one is over 1, so it's x to the fourth over x to the fourth. And it's 8x squared e to the x squared. And because we have a subtraction, we're going to add on the opposite, or put a 1 here. So negative 1 times this fraction is a negative 4 over x to the fourth. Negative times a negative is positive, so it's a positive 3 ln x to the fourth over x to the fourth. And so right now we have one fraction. So we have, all of the denominators are going to be the same. So this is 4x to the fourth ex squared. And this is 8 plus 8x to the sixth ex squared minus 4 plus 3 ln x to the fourth. And none of these terms, this one has ex squared, 2 of these, but that's x to the fourth, x to the sixth. So none of these can be added together. So that's the single fraction that represents the derivative of this expression right here. Again, a little bit of algebra involved, but when you're sharp or you know what you're doing with your algebra, then the calculus becomes easier. And that brings us to the end of this video. And again, if you're liking the video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.